Okay, so hi guys. This is a exercise from Khan Academy. So we are going to talk about the proving triangle similarity. Okay, so before we get into maybe problems, so I just need you to remember we have three ways that we are going to use to say the triangles are similar. So the first one is angle angle, and second one is side angle side, and the third one is side side side. Okay, so whenever you can show two figures having two same angle measure, with even though sometimes you don't really know their measure, but if you know their value is the same, that will be enough. So when you can show two figures have the same two angles, then they are going to be similar. Or if you can show two sides are proportional, okay, and the angle in between those two proportional sides are equal, then they will be similar. Or if you can prove all three sides are proportional, and then they are going to be similar. So when they are similar, when you show they are similar, as a result, you are going to conclude that they will have the same angle measure and the size will be proportional. Let's say you prove that the size are proportional, right? And then that will like that will help you to say they are similar, which will be something you are going to able to say they will have the same angle measure, okay? Or if you can show two angles are equal, okay, then they are going to be similar. Then if they are similar, then their size will be proportional. So you are going to kind of find more information about those triangles when you have something. Or if you have two sides, one angle in between, then if two sides are proportional and the angle in between is equal, then you can say their other angles will be same, or the third side is also proportional, okay, and stuff like that. So we are going to use these three. So let's look at this one. But as you see, we don't have really the side information because there's no numbers given. So we cannot really use the last two, but maybe we can try just angle angle, but it doesn't look like we have angles either. So, but we have 90 degrees and we have 90 degrees. Maybe that's one pair, but I need at least one more angle that will be the same, right? So here's the thing, like, if you look at the triangle, it says EFG, which is this guy, okay? And we are going to compare with the dashed triangle, which is the larger one, okay? So to make this a bit easier to visualize, I'm going to make actually two separate triangle from that given figure. So you can easily like see what's going on. So that's F, that's E, and that's H, so which is 90 degrees. The angle F right here, okay, in this triangle, I don't know the angle measure, but let's call this is alpha. And this is the same F, right? So this F is actually the same angle. So that means this angle in my larger triangle is also alpha. So which is actually enough to say, this is alpha, this is 90. This is alpha, this is 90, which means you already had two angles are equal, even though you don't really know their measure. I mean, alpha, angle alpha, but you know that you see that is the same spot in both triangles. So that's shared angle. So then that will be enough for us to say this triangle and this triangle are similar. But if you like to make a bit more angle chasing, so you can say maybe this is beta, which is alpha 90 and something, alpha 90 and something. So since the sum of those three is 180, this guy is going to be also beta as well, because if you prove two angles are the same, the third needs to be the same, which is beta in both cases. So now let's look at the corresponding angles. And EFG, E is my like the triangle EFG is this triangle, larger one, the dash one, but I didn't draw dash one, dash way. So angle E is the 90 degrees. In my smaller triangle, okay, no, actually EFG is this triangle, smaller one. This is my dash triangle. So this side, angle E in my this triangle is actually this guy, which is beta, angle beta. The beta is H, so that means this guy has to be H. And then F in my smaller triangle right here is at angle alpha. Angle alpha is F, so that should be same point, which is the same angle. And then G, which is going to be smaller triangle, is G, is 90 degrees. That's actually corresponds to E. So I should be getting these guys, okay? So let me change those. So H has to be here, F has to be there and E has to be there. Okay, I think that's correct. So let's move on to the next one. So now we have a proof question, and the question was asking, the guy was curious if these two triangles are similar. He wrote the proof that and came to the conclusion they are not similar, but the proof is wrong. Okay, so what is wrong with the proof? Okay, so before we see the choices, like there are some choices like this, but before we see that, let me see what's going on. Okay, so make sure you remember angle, angle, side, angle, side, 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 side. We have three ways to decide if the figures, if the triangles are similar. Okay, so we have something going on right here. Before we look at the choices, I'm going to just draw whatever I can. So now these two angles are actually congruent each other, because if you have two lines are intersecting at a point, the angles on the other side, which is something I probably say a lot, and these two guys are called vertical angles, or this guy and this guy are called vertical angles. So when you have some vertical angles, they will be congruent to each other. Okay, so that is why this angle and this angle are equal to each other, which is good because I have one angle. But other than that, I have no idea about the other two angles. So which means I cannot probably use this guy. I cannot use this either because the third side is not given. So only shot that I have is the side angle side, which is why I do know the angle is equal in between the given two sides, but I need to show those sides is like proportional. Like if you look at this 8, which is my smaller of these two, so 8 divided by 6, which is the like corresponding this like side to this side, because that's the smaller one, and that is 4/3, and then 20 divided by 15 is also 4/3, right? So which is why when you prove two sides are proportional and the angle between those two are equal, and that makes they are similar by side angle side, which means they are similar. So let's look at what they did. Okay, so they did say BCA, like BCA, which is this right angle, is congruent to ECD, which is this right angle. So that is equal to each other. The reason is vertical angle. That is correct. And now AC, which is this 20, divided by CD. CD is 6. Okay, they did this divided by that. Okay, 3.3. And BC divided by CE, that's 0.5. Okay, so there is something wrong right here because AC and CD are not the corresponding sides, because when you look at those sides, this is my smaller of these two, and this is smaller of these two. If you can like prove they are similar, you just probably say the smaller side corresponds to the smaller one, larger one corresponds to the larger one. But they did the other way around, so they just divide the larger number by the smaller, like smaller number by larger. So that's why they got two different values, which doesn't make sense. Okay, and then they said these are not equal, so that's why they are not similar. But that's wrong, right? So the thing that they did wrong, they divide the wrong side. They just compare the wrong sides. Okay, so let's look at what we have. So the angles are complementary, not congruent. So no, that was correct. They are vertical, and the side BC is not 8. BC is 8. That's correct. Side AC does not correspond to CD. Okay, this is correct. Like AC doesn't correspond to like CD, right? That corresponds to CE. And then he should compare these two. It says just choose one answer, like AC and CD. Let me check that one as well. AC. So let me clear this one. AC and CD. No, AC and CE has to be for like taken ratio. They has to be compared, AC and CE, because AC is my larger side and this is my larger side of those two. So that's wrong as well. Okay, so I'm coming with this C, so that needs to be our answer. Okay, yeah, that is correct. Again, we did 2 questions, so I hope that makes sense and helpful. Okay, so I'll see you next time.